Okay, hi, I'm Mr. Kwong. We're going through question 2 with you from the block exam paper 2. Alright, so question 2, you have a cubical box of side L. Let me just highlight the terms for you. Side L, which contains m molecules, each of mass m, all moving horizontally with speed c at right angles to the wall A. Alright, so basically they're all moving along this axis only. Okay, they are horizontally, that means they are moving on this plane here, okay, and they are at right angles to wall A, so that means effectively there's only one direction they can take. Okay, so they are moving along this plane. Alright, so there's no need for you to define cx, cy, cz. There's no need for you to do it. It's just speed c just this way. Alright, okay, then what else is there for you to not do? Okay, there is no need for you to make other assumptions about right angles because the told is right angle already. Alright, so let's go on to this question here. There are several assumptions in the kinetic theory of gases. State the assumption that describes the interaction between the molecules of the gas and the walls of the box. So if you wrote things like, energy is conserved. Okay, if you write energy is conserved, right, technically you're not wrong, right? Because energy is always conserved. Okay, but here specifically, right, you're talking about kinetic energy of the molecules are being conserved, right? Conserved between collisions, right? So the actual answer we're looking for is basically, right, your collisions between molecules and wall are elastic. Okay, so it's really hard to, you can write about kinetic energy, but it's very hard for you to write it clearly enough lah. It's very easy for you to make mistake, but this one is basically a one liner that is fine. Okay, so some of you also wrote stuff like molecules are very far apart, molecules don't often collide each other, etc. Or the volume of the molecules is very small compared to the volume container. Yes, they are all correct, but then this is clearly about the interaction between the molecules and the walls of the box. So it's very specific here. Okay, so there is no other answer that can be accepted here. Alright, next. State expression for the momentum of molecule just before a collision with wall A. Okay, so look at this one. This molecule has a speed of c, so this is just p equals to mc. Alright. Oops, sorry, I dropped my pen. Okay, p equals mc. Some of you wrote p equals to mcx. Again, this is already they already defined for you as it's already horizontally with speed c angles, right angles to wall A. So there's no cx here. Okay. Some of you wrote this one, I give BOD, I accepted this. Some of you wrote P equals to MV. Okay, why is there a V? They told you C already, why you go and change this to C? So this is wrong. Okay, some of you go and let V be C. No, please don't do that. They already told you C, just stick with C. Okay, don't be extra and go and change to whatever terms you want. I accepted a negative sign. That's fine. I accepted a negative sign here because you were looking at this one going to the left. That's fine. I'll accept that. It's not the most important thing here. Okay, even though strictly speaking, say before colliding wall A, right? It has been moving this direction now. But again, this is down to which direction they are taking as positive. So I will close one eye for that. Okay. Then for this one here, deduce the change in momentum of molecule makes a collision of wall. So let's just quickly sketch a diagram for you to see what's going on. If this is wall A, molecule comes in here with speed c, goes back off with speed negative c. Okay, so your change in momentum is final minus initial. So this is negative m negative c minus mc. So I have negative 2 mc. Okay, without minus sign, I'll take it as well. So that's fine. Alright, so this is it. Okay, so 3 marks actually quite easy to get on the first page. Alright, but let's look at the next page. So basically this question is to guide you to proving your answer. Okay, state the time, determine expression for time taken by one molecule between collisions with wall A. So let's just draw out this distance here. Okay, let's just draw this square here nicely. Okay, let's draw this square. Okay, can. Alright, so this distance here is L. Let's mark out this distance. This distance is L. Okay, your molecule is going this way. Your molecule starts from after it first collides, right, it starts from here. It has to travel all the way to this side, travel L, then come back here. This is L and this is L. Okay, so this the before it next collides with the wall again. So your speed is time taken, right? Your time taken is basically the distance traveled divided by velocity. So this is L plus L over C, so it's just 2L over C. Alright. Then for the next one, you find the total number of collisions per unit time made by one molecule. Okay, so 2L over C is the time between one collision, right? So basically you're finding, so this essentially, this one here is your period. Okay, this is your period. Okay, so to find this frequency, right, this is just frequency just 1 over T. So this is 1 over 2L over C equals to L over 2, what am I doing? Equals to C over 2L. Okay, right. Then here, this one, a lot of you try to, obviously you couldn't do the first two parts, and then you try to reverse engineer this to get the NMC square over L. You cannot do it that way, okay? You can't sub in random symbols to make it equal. Okay, average force exerted by one molecule. Okay, so remember, most of you know that, okay, for one molecule, okay, you know that F is equals to delta P over delta T. And then go from the previous page, right? This is equals to 2mc divided by delta T. Delta T is a number of, it's a time between collisions. Okay, so this is 2L over C. 2L over C. Okay, so this one you rearrange this, right? You get 2mc square over 2L. So you have mc square over L. Okay, then for n molecules, right, your force is equals to n times mc square over L. Okay, so you have n mc square over L. For this question, right, I was quite particular about what you chose to substitute in. You need to show that you clearly understood what's going on instead of just random substituting numbers, random substituting equations that even though they're correct, right, but it doesn't fully show your understanding. Okay, so for this question you may want to write a statement instead to make it clearer. Okay, determine average pressure. So this one also I was very nice because you know that pressure is just force over area, and you could most of you could sub in nmc square over L, then you divide it by A. Most of you could see that, oh, this is A is equals to nmc square over L square, and then you get nmc square over L cube. I also accepted nmc square over V, which is basically volume, or nmc square over A. Okay, even though you should be able to recognize that A is just area just equals to AL. Okay, I took it as well. Okay, decided to be nicer here. Right, so that's all for this question. Thank you.